So welcome to this segment as I try to continue with 2024, 2024 GCE Paper 1 Physics. So I'm starting from question number 810, and it says a ray of light enters a block of glass from air and emerges at an angle of 25 degrees. What is the angle of incidence of the ray if the refractive index of the glass is 1.5? So they have given us the refractive index is 1.5, then they want us to find the angle of incidence, which we don't know. Then it emerges, or the angle of refraction is simply 25 degrees. So you can apply Snell's law. The refractive index is equal to sine I over sine of R, but you want to find that, so I can say over 1. So it will be sine I is equal to the refractive index multiplied by sine R. So it is going to be sine I, the refractive index is 1.5 times sine 25 degrees. So it will be sine I is equal to, so when we multiply, 1.5 multiplied by sine 25, that is giving us 0.6339. Let me just leave it to 4 decimal places. It's actually good when you're finding an angle. So to find I, that's the angle of incident, I'll now say the sine inverse of this value 0.6339. So sine inverse of this value that we do have, it is simply giving me 39.3 4 degrees. So they left it to 2 decimal places, but of course angles can also be left to 1 decimal place. It's actually sometimes the best. So you can see that C is actually the best option. Sorry, I covered it with a paper because there were a lot of markings that were there. Let's move on and try to see what we can do. A11 says the following diagram shows 2 rays of light passing through the lens in region X. Of course, the type of lens that produces such an image is a convex lens, so we expect to have a convex lens, which is also known as being a converging lens. So if the object and the image are on different side of the lens, then the image is actually real. It can be formed on the screen. No wonder you're able to see it is upside down. So indeed A was the correct answer that you needed to have there. Then the following diagram shows the magnetic field lines around 2 magnets. Sorry, we were trying to answer previously, but the video didn't come out well. So remember, how can you know which one is north and south? Well, when it is a north, the rays will be moving out, but if it is south, the rays will be coming in. So you can see the arrows are going in, so that's a south. The rays are moving out, that's a north. The rays are moving out, that's a north, and they are coming in, that means it's a south. It's a south, as I've indicated there. And the point between 2 like poles is simply called neutral point. But because it exists between magnet, if you want, you can call it a magnetic neutral point. And therefore, C is the best option. P is south, N is the north, R is the north, and T is simply south, and that's a neutral point. So C is actually the best option there. And then the other thing I'll cover slightly so that I can give you a clear idea. The diagram shows a negatively charged rod brought near a metal sphere on an insulated stand, and the metal sphere was earthed. Later, the rod was removed and the earthing also removed. So remember, when you bring in a negatively charged rod this side, electrons will be pushed, and hence you are going to have protons this side. When it is earth, it simply means that when you earth or connect this side to the earth, the charge will be shared. So the electrons, since they are able to flow, will move from the sphere into the ground, and that will leave those that are positively charged. When you're drawing that in the exam, if you use 3 positive, make sure you have 3 negative. If they are 4 positive, make sure they are 4 negative, and maintain that. Very important. So what will be the net charge possessed by the metal sphere? Definitely to remain with a positive charge. Now if you look at this one, this is F14. It says how long would it take to charge a cell phone battery to a charge. So they have given us a charge of 54 coulombs using a voltage of 6 volts and a current of 2.5 milliamps. So you will need to convert this one to amps. Remember, 1 milliamp is equal to 10 raised to the power negative 3 amps. So in simple terms, when we convert this to amps, it will be 2.5 times 10 raised to the power negative 3 amps. So you can know how long, that's the time the question is asking us. Remember, charge is equal to current times time. So if you make T the subject of the formula by dividing I, it will be charge divided by time. So the charge is simply 54 coulombs over, you divide the current, so this is the current. So the current will be 2.5 times 10 raised to the power negative 3. So what is that going to give us when we work out that? It will be 54 divided by 2.5. Let me just do it nicely. 2.5 exponent negative 3. And that is simply giving me 21,600. But remember, this is going to be in seconds. But the answer here that they gave us there was nothing in seconds, it was in hours. So we can change that one. Remember that 1 hour is equal to 3,600 seconds. So you can say, what about if I have 21,600 seconds? Then how many hours would that give me? In simple terms, we'll take just 21,600. We divide by the 3,600. The 2 zeros will cancel. So if you want, it is 216 divided by 36. And that is going to give me 6 hours. But if you notice, there was no answer here. Probably the people that were preparing, when they were preparing it, they didn't do it well. Perhaps they might have they didn't do a proper conversion. They might have said time is equal to charge divided by current, where they took 54 and divided by just 2.5. So 54 divided by 2.5, it is simply giving them 21.6. So it is giving them 21.6, and they put up hours. This is actually very wrong. So there was no answer here actually. So here, there was no answer actually, because they did a wrong conversion and put up those multiple choice. All right. That's why you see me, I cancelled. I was using a plain paper. Let's move on and see if we can help you with 15. It says the cost of electricity for using a kettle is 80 kwacha at a cost of 0.65 or 65 ingwe, 0.65 kwacha per kilowatt. It takes 5 minutes to boil water in a day, and the kettle is used for 30 days. What is the power rating of the kettle? So they want you to know the power rating in this case. Now remember, according to the time, it takes 5 minutes to boil water in a day. That's what they mean. And the kettle is used for 30 days. So what we can do is that since in a day it is 24, so it will be 5 minutes multiplied by, so in a day it actually, if you wanted, you can say in a day it actually takes about 5 minutes in a day. Then what about 30 days? Then how many minutes will it take? In other words, you multiply 5 times the 30 days, and that is going to give us 50 minutes. So it will take 150 minutes in this case. So they want the power. That's what the question is asking us. So what is the power that we have? All right. So this we can convert it to hours, because we know that 1 hour is equal to 60 minutes. So you divide this by 60. So 150 divided by 60. And that is going to give us 2.5. So that would be 2.5 hours. Now, if you remember, electrical energy is equal to power times time. We know the time, which is here. we want to find the power. But the question is, do we know the electrical energy? Yes, we can calculate, because they told us that the cost of electricity for using a kettle is that at a cost of that per unit. So meaning, per kilowatt hour, that amount of energy, it is costing 0.6 5. Hopefully you're following me. So you can simply say, what about 80 kwacha? Then how much electrical energy? So we can actually cross multiply. I can see x will be 80 divided by 0.65. So it will be 80 divided by 0.65, and that is going to give us that is almost 123 kilowatt hour. So that's the amount of energy. So I can say 123 kilowatt hour is equal to the power we don't know, and in this case the time is what we found, 2.5. So we can divide 2.5, even that side 2.5. So power will be equal to, it will be 123 divided by 2.5. And what is that going to give us? All right, so it is going to give us 49.2, in this case kilowatt. So that's the power, and you can see this is actually the answer that they wanted you to get. It was a bit tricky, but you just need to follow the steps that I've given you here, then you're good to go. It says a transformer has 1,800 turns on the primary core. So the number of turns in the primary, 1,800. The voltage applied to the primary core is that. Voltage primary is 240 volt. How many turns are on the secondary core if the output voltage is that? So they want us to find the number of turns secondary if the voltage in the secondary is 40 volt. Remember, you apply the formula, number of turns primary over number of turns secondary is equal to voltage primary over voltage secondary. So it's just a matter of replacing the number of turns in the primary is simply 1,800 over the number of turns you don't know. The voltage in the primary is 240 volt, and the voltage in the secondary is 40 volts. So when we cross multiply, NS will be this times that, 1,800 times 40, then we'll divide by 240. So this 0 and that will cancel. 4 there, 1. 4 into 24 is 6. 6 there, 1. 6 into 18 is 3. And you can see that that is going to give you 300 turns. So that's what we mean there. All right. Let's move on and finish up our multiple choice. Hopefully it helps you as you prepare for the exam or as you study. The following diagram shows a simple AC generator. What name is given to the part Y? So the part Y, if it's a complete ring, we call it as being a slip ring. But if it is half a ring, then it is called a split ring commutator. So they're both commutators. This one is a complete ring, it's called a slip ring, but if it is split, it's called a split ring. So this is representing a slip ring, and attached to the ring are what we call as being carbon brush, and these are representing permanent. These are representing permanent magnet, and the one in the middle there is simply called the armature, sometimes called as being the coil. That's what you need to remember. They are going to ask you about that in later discussions. A18 says that which particles are emitted by the hot filament of a cathode ray oscilloscope, and what type of field is used to accelerate them. What type of field is used to accelerate them? So basically, what particles are emitted, they are simply electrons are the ones that are emitted. Then the type of field that is used to actually accelerate them is simply an electric field. So I would go for A as being the best option. 19, which of the following shows the correct charge for alpha, beta, and gamma radiation? So that in terms of charge, alpha have got a positive 2 charge, beta have a negative 1 charge. Remember, alpha is simply an helium nucleus, Beta is simply a fast-moving electron, and gamma rays are electromagnetic wave, and they have got no charge. So we simply say they are neutral, or they have a zero charge there. So the best option, is 2, -1, and 0. So C was the best option there. A nuclide of strontium is represented by the symbol. What does the nucleus contain? So what does the nucleus contain? So from there, the number of protons is equal to 38. Now, if the number of protons is 38, it simply means the number of electrons will also be 38. And you can know the number of neutrons by getting the mass number, or the nucleon number on top, 88 minus 38. And when we subtract, that would be 0, and that would be 50. So they are. So if you notice from here, what can we say? They are 50 in terms of when we talk about the number of neutrons, how many neutrons are there? The neutrons are 50. So this, and the number of electrons, yes, 38. The number of protons are also 38. So which one would be the best option? Remember, it says, what does the nucleus contain? So in the nucleus, you find that there are only protons and there are only neutrons. So the question is focusing on just protons and neutrons, because it talks about the nucleus. So the proton is 38 and the number of neutrons is 50. So D was the correct answer. Thank you so much for watching. Watch out for some other videos, even in chemistry, where we actually revise and help you to be stabilized as you study. Thank you for watching. Subscribe if you love what we do, and share. Thank you.